The essential question for this lesson is, what properties do squares and rhombi have? So squares and rhombi. So let's start with the rhombus. Our definition of a rhombus is a quadrilateral with 4 congruent side lengths. Remember, the definition is the minimum amount of information you need in order to call it a rhombus. So on my diagram, I am going to mark that all 4 sides are congruent. That is the definition of a rhombus. We discovered that rhombi also have several properties that are true. So here's the list of all of the properties that are true. And in the case of the rhombus, a lot of the properties that we figured out were based on reflection symmetry. The rhombus has reflection symmetry. I can fold it in half along the diagonals, and then that's going to help me discover some of the properties about it. The first property that I discover is that the opposite angles are congruent. Opposite angles are congruent. So I'm going to mark those in my diagram. So the opposite angles are congruent. The next thing I remember about a rhombus is that's a parallelogram. So the opposite sides are going to be parallel. So I would mark my sides with the arrows to show that they're parallel. And then these 2 sides would have double arrows to show that they're parallel. Since the rhombus is a parallelogram, all of the things about a parallelogram will be true for a rhombus as well. That's how we got the opposite sides being, the opposite angles being congruent. Opposite sides are also congruent, but since all 4 sides are congruent, that would be redundant. We don't need to add that one. Let's talk about the diagonals. The first thing that we learn about the diagonals is that the diagonals bisect the angles. That means that the angles get cut into equal halves. So that means that those 2 are going to be congruent, and those 2 will be congruent. And since the opposite angles were already congruent to each other, all 4 of those angles will be congruent to each other. And then same thing with this pair of opposite angles. Cool. What else did we discover about the diagonals? We discovered that the diagonals are perpendicular bisectors. That means they hit each other at a right angle. They're perpendicular bisectors. So they hit each other at a 90-degree angle. And since they are bisectors, that means that they cut each other into 2 congruent halves. So the diagonals of my rhombus create 4 right triangles. And if I have right triangles, that means that I can use the Pythagorean theorem to solve some problems. Let's talk about the square now. The definition of a square is a quadrilateral with 4 right angles and 4 congruent side lengths. So I am going to mark my 4 right angles. That means that a square will be a rectangle because a rectangle has 4 right angles. And I will mark my 4 congruent sides. That means a square is also a rhombus because a rhombus has 4 congruent sides. And we know that rhombi and rectangles are also parallelograms, so that means a square is also a parallelogram. It is the most specific parallelogram and rectangle and rhombus that you can get. Okay, so let's talk about the properties. Properties, opposite sides are going to be parallel. So I'm going to mark that on my diagram with the arrows that indicate that the sides are parallel to each other. So I have two sets of parallel sides. That's what makes it a parallelogram. Parallelograms also have the property that the opposite sides are congruent, but we already know that because all four sides are congruent in our square. And they have the property that the opposite angles are congruent, but we already know that because all of our angles are already 90 degrees. So we don't have to specifically go in and say those two things because they're kind of already taken care of with the definition of the square. Since it's a rectangle, we know that the diagonals are going to be congruent to each other. And since it's a rhombus, we know that the diagonals are going to be perpendicular bisectors of each other. So what that means is in our diagram, we can mark that the diagonals are at a 90-degree angle and that they bisect each other. But since they're also congruent to each other, that means that all four segments that they create are going to be congruent. So that would be what we would mark for that. And we know that the diagonals bisect the angles. So we can mark that in here as well. And since each angle is 90 degrees, the angle that's created when it's bisected is going to be a 45-degree angle. That means that the diagonals of our square will actually create four, not just four right triangles, but four isosceles right triangles. So the diagonals create four isosceles. Remember, isosceles means that two sides are equal to each other. Right triangles. So again, with a square, we'll be able to use the Pythagorean theorem. And since we know that the legs are the same, we could probably also use that idea to solve some problems as well.